Fifth graders, this is your Unit 7.5.2 Statistics Test Review video. So this is getting close to spring break. So let's get started with our review. Question number 1 says, Ming conducted a survey to determine the favorite flavor of ice cream in her hometown. 15 of the 50 people she surveyed liked strawberry best. How many of the 3,500 residents in the town would you expect to like strawberry best? So we're looking at a survey, and there's some important information in this survey. The first piece of information is that she surveyed 50 people, and 15 of those liked strawberry best. The question asks us to make a prediction that if she surveyed the 3,500 residents in her town, how many would you expect to like strawberry best? So we're going to use the start of our information that it was 15 out of 50. So that was 15 people who liked strawberry out of our total number of people. So I have that. Now we don't want our total number of people to be 50. We want our total number of people to be 3,500. So we are increasing our sample. And our job is to find out how many of them would we predict to like strawberry the best. So when we solve this problem, we can use cross products and we can multiply 15 times 3,500 and 50 times x. So let's write that down. 15 times 3,500, and that's going to be equal to 50 times x. So we have a little bit of work to do. So I have 50x on this side, and we have to multiply 15 times 3,500. But we can do a little bit of shortcut and just multiply 35 times 15 and then add 2 zeros at the end. So when I multiply 35 times 15, I end up with 525, and then I'm going to add 2 zeros. So 5, 2, 5, and then add 2 zeros. So after that multiplication, our next step is just to divide each side by 50. So we're going to divide each side by 50. So we're going to take 52,500 and we are going to divide that by 50. So when I start my division, 50 doesn't go into 5, but it goes into 52 once. So that would give me 50. Subtract. I have 2 left. Bring down my 5. Well, 50 doesn't go into 25, so I have to put a 0 up on top. And I'm going to bring down my other 0. So now we're doing 50 into 250. And that gives me 5. And that goes in exactly. So I have 0 left. But remember, we still have that 0 up at the top that we would need to bring down. So that means we need to add a 0 up here at the top. So our answer is that we would expect 1,050 residents to like strawberry. So x equals 1,050 people. And that is our final answer for problem number 1. Question number 2. It says use the box and whisker plot to determine which statement is true. So this time we have a double box and whisker plot. We are comparing the average monthly temperatures for New Orleans and Indianapolis. So we're going to look for the true statement. So we have three choices. We're going to go through each of the choices. Remember, the dot to the far right is your lower extreme, lowest piece of data. This dot right here represents our lower quartile, which is the median of the lower half of data. Our median is the line that's somewhere inside our box. Then we have the upper quartile, which is the median of the upper half of data. And the last dot represents our upper extreme, our largest piece of data. So now we can go through and start analyzing and checking to see if the question is true or false. So statement A says, the average monthly temperatures of New Orleans are not as varied as the average monthly temperatures of Indianapolis. If our temperatures were to be varied, that means our box would be very large and that our box plot would be very spread out. So our statement says that the average monthly temperatures of New Orleans are not as varied as the average monthly temperatures for Indianapolis. So if we look at our New Orleans plot here, we can see that our plot goes from about 52 to maybe 82. So that would be about 30 for the range. For Indianapolis, it goes from about 27 to maybe 77. So that range would be about 50. So New Orleans is definitely not as varied. So right now it's looking like A might be our correct answer, but we're going to check our other options as well. B says the interquartile range of the average temperatures of New Orleans is greater than the interquartile range of the temperatures of Indianapolis. So remember, the interquartile range is the difference between the two edges of our boxes. So our IQR, which stands for interquartile range, for New Orleans is 80 minus 60, which gives us an interquartile range of 20. If we look at the IQR, the interquartile range for Indianapolis, we're looking at about 69 to about, I don't know, 37. So 37 to 69 is probably about 32. And our statement says the interquartile range of New Orleans is greater than. Well, we can see that Indianapolis is greater. So that makes statement B false. Let's look at C. The median of the average temperature of New Orleans is equal to the upper quartile range of the average temperatures of New Orleans. So let's talk about it. Our median that's here, remember the median is inside your box. So here is our median for New Orleans right here. And it says is equal to the upper quartile or average monthly temperature of Indianapolis. So remember, this is our upper quartile. If we look, they look like they're in the same place. So that looks like it might be in a true statement as well. Let's look at D. Half of the average monthly temperatures of Indianapolis are less than half than the lowest average monthly temperature of New Orleans. So if we look, remember, each dot to dot represents 25% or 1/4 of the data. So it says half of the average temperatures of Indianapolis are less than the lowest average temperatures. Okay, so here's our lowest average temperatures for New Orleans. So they're down here. And if we're looking at half of our data, that goes to up here in Indianapolis. So this is also a true statement. So let's go back and look at our question. Maybe our question is to say which one is not a true statement. So if we look at this, we found 3 of our 4 statements to be true statements. So the only one that was a false statement was answer choice B. So we are looking for the not true statement instead of the true statement for number 2. All right, moving on to number 3. Which type of graph will be most appropriate to display all of the times for 10 runners in a race? So we want to display each person's times. So if we start looking at our different options, if we look at a circle graph, a circle graph is not going to display each of their times. Okay, circle graph represents the part to a whole, and we are not comparing any parts. We want to see all of their information. If we're looking at a dot plot, we will see on a number line the information, so we could see their individual times. So maybe it's a dot plot. If we look at a box and whisker plot, remember we are displaying the median of that data, and we are breaking it into 4 sections. So we don't want to do that because we don't want to display the median. We want to display every piece of data that we have. The best choice for displaying all of our data for 10 runners is going to be a bar graph. We can have each runner's name under their bar, and we can have the appropriate time going for that runner on our y-axis. So a bar graph would be most appropriate to display the runner's time for 10 runners in the race. Moving on to number 4, it says the dot plot shows the ages of people in a play. Which of the following statements is true? So remember, a dot plot is always going to be on a number line, and it tells us how many people in the play are at that age. So we can see there's nobody age 15, nobody age 17, nobody age 22. We can see that all the people in the play are from the range of 16 to 21. So we're looking for our true statement out of our options. A says the median of the data is 18. Remember that median is the middle number. So we would kind of have to work our way back towards the middle. So if I was crossing it out, it's 1 from the front, 1 from the back, 1 from the front, 1 from the back. And we keep working our way, 1 from the front, 1 from the back as we go. And we discover that our median would actually be 19, those 2 pieces in the middle. So statement A is false. That is not the correct answer to our problem. So now let's have a look at statement B. It says the range of the data is 7. So remember, range is highest minus lowest. So our lowest is 16 and our highest is 21. So if we have 21 minus 16 for the range, that would give us our range as being 5. And it says here the range of our data is 7. So statement B is a false statement. Now moving on to statement C. Mode. Remember that a mode is when the data appears most often. You could have no mode, you could have one mode, you can have more than one mode. So this one tells us that the data pieces that appear most often are 18 and 20. So let's go have a look at 18. And I see that there are 3 people age 18. And if I look at 20, I can see that there are also 3 people for age 20. None of the other pieces of data have 3. So that makes statement C a true statement. And remember, we were looking for that true statement. But we're going to check statement D as well. It says there are fewer than 10 people in the play. So if we count, remember each dot represents a person. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 people represented in our display. So statement D is false. There are not fewer than 10 people in our play. Let's pause here and get your work down for this problem. All right, moving on to number 5. It says the circle graph below shows the results of favorite colors. If there were 75 students surveyed, how many more total students were there than those who chose red as their favorite color? So this problem requires a little bit more work on our part. So we are comparing the total number of students to those who chose red. So if we look at our circle graph, it tells us the percents of each color. 36 for blue, 7 for yellow, 30 for black, 12 for red, and 15% for orange. Remember, that does not mean the number of people. That is the percents. So that means we're going to have to set up our percent bar. So remember, we always put down 100% first. So that goes here. And our 100% number is 75. That is the total number of people in the survey. And we are specifically focusing on red. So that was 12%. Well, 12% is kind of way down here, so that should not be that big of a number. And we're trying to find that answer. So we have our box set up for us. And we're going to have our proportion. So I have x over 12 equals 75 over 100. So now we're ready to solve this problem. We're going to do cross products. We're going to cross multiply 12 times 75, and that's going to be equal to 100 times x. We already know this part on the right is 100x, so the only thing I have to do is go multiply 12 times 75. So when I multiply 75 times 12, I end up with that answer being 900. So we're going to take 900 and we're going to divide it by 100. So when I do that, when I divide 900 by 100, I get x equals 9. But that represents the number of people that chose red. So 9 out of the 75 people surveyed chose red. But remember, our question says, how many more total students were there that chose when compared choosing red? Okay, so how many more? We're looking for the difference between the ones from the total to the ones that chose red. So we've got to take 75 and we are going to subtract 9 to get that difference. So when I subtract, that's 6. That's 15. 15 minus 9 is 6. And we have our 6 there. So we have to answer this question. How many more total students were there than those who chose red? So if 9 students chose red, that means there are 66 other students who chose some other color other than red. Those were the students who did not choose red. So you may pause here and get to work for this problem. All right, moving on to problem number 6. Says which of the following is a true statement? So again, we're looking for the true statement about the bar graph below. So here's our bar graph, and we can see they've done a good job for us. They put all of the numbers on top of the bar, just like I would expect you to do when you number your bars if you have a bar graph on your test. So this bar graph shows the rides taken, so the number of rides, by each one of the people. So we're going to look for that true statement. So A says Maria and Haley took more rides combined than all of the other riders. So we're going to start with looking at Haley and Maria. So we're looking at Maria plus Haley's, and that's going to be equal to 6 for Maria plus Haley's 7 for a total of 13. So we know there's 13 when we added them together. But the statement says that they took more rides combined than all of the other riders. So we're going to look at all of the other riders now. So is that Amir, Dexter, Cheyenne, and Yoko. So we're going to put those four together. So Amir plus Dexter plus Cheyenne plus Yoko. And we're going to see if Haley and Maria totaled more. So Amir had 4 plus Dexter's 6 plus Cheyenne's 4 plus Yoko's 3. So when I add all of that together, that's 10 plus 7, and that gives me 17. So as far as I know, Haley and Maria's 13 is not greater than 17. So statement A is incorrect. So now let's look at statement B. So it's the fraction of the rides that Dexter took totals 1/5. So we first need to add our total number of rides as well. So if we just thought about what we had for A just a minute ago, we can add all this together. So 6 plus 4 plus 7 plus 6 plus 4 plus 3. So we add all this together, that's 10 plus 13 plus 7. So that gives me 20 plus 10, and that gives me a total of 30. So I know our total is 30. So we're specifically looking at only Dexter's information. So Dexter had 6 out of 30. So 6 out of 30. So I have to take Dexter's fraction and I have to simplify that information. So remember, when I simplify, we divide the top and the bottom by 6. So that gives us 1 out of 5. So right now that's looking like a true statement. So let's check statement C. So when I check statement C, it says that Yoko took more than 10% of all of the total rides. So we know that our total rides was 30. And Yoko's represents 3 out of 30. So I'm going to simplify that by dividing the top and bottom by 3. So we'll divide by 3 here because 3 goes into each one. Divide by 3 there. And I get 1/10. Well, 1 out of 10, remember, percent means out of 100. So let's make that into a percent. So we can multiply by 10 on the bottom. And we can multiply by 10 on the top. And so that gives us 10 out of 100, which is exactly 10%. So if we look at our statement, it says she took more than 10% of all the total rides. And she did not. She took exactly 10%. So that makes statement C false. So let's look at our final statement. It says the mean of the number of rides taken is greater than 6. Remember, mean means average. So we would add all of these up and divide by 6. Well, we've already added them all together already. We know that answer is 30. And we have 1, 2, 3, 4, 5, 6 different people. So if we take 30 divided by 6, that gives us our average, or our mean, as being 5. And the statement says that our mean is greater than 6. And 5, as far as I know, is not greater than 6. So that means D is false. So B is indeed the correct answer to this. So make sure you pause down, get any work that you needed to have for this problem. For problem number 7, it's broken down into 4 parts, and we have this bar graph, and it shows the results of the survey of Hamilton Middle School 7th graders. And it says use the bar graph to determine the following probabilities. So the first thing we're going to do is label our bar graphs and with the number above each bar. So that was 17 for entertainment, 14 for education, 11 for medicine, 6 for public service, and 2 for sports. The second thing that we're going to need to do is total all of these up together. So we're going to add up all of these numbers. So 17 plus 14, that's 31. And 31 plus 11 gives me 42. And 42 plus 6 plus 2 is 8. So 42 plus 8 gives me a total of 50. So I know that this bar graph represents 50 total people. So now we can answer our question. It says the probability of choosing a career in public service. So remember, probability is what we want. So public service, which is 6, out of our total, which is 50. But remember, you need to simplify your probabilities. So we're going to end up dividing the top and bottom by 2, because 2 goes into each one. So 6 divided by 2 is 3. And 50 divided by 2 is 25. So my final answer for problem number 1 is 3 out of 25. It's kind of a low probability. Let's look at number 2. Probability of choosing a career in education. So education was 14 out of the same 50 that we started with. And again, I can simplify by dividing the top and the bottom by 2. So when I divide, 14 divided by 2 is 7. And 50 divided by 2 is again 25. So our probability for education was 7 out of 25. The next one, a probability of choosing a career in sports. So sports is 2 out of 50, so that's even lower. And again, we can simplify by dividing the top and the bottom by 2. And our probability is that there is 1 out of 25 chance that you would have a career in sports. So the probability questions weren't too hard. Remember, probability is what you want out of the total. So now we have one more question to answer. And it says, predict how many students out of 400 were into the education field. So we're going to go up here and use education that we were already using. You can start with your original probability of 14 out of 50, which might be a little easier, or you could use 7 out of 25. You should still get the same answer. So I'm going to go ahead and use 14 out of 50. And this 14 was education, and our 50 was our total number of students. So now they want our total number of students to be 400. So we've got to solve this problem. We could use cross products and multiply 14 times 400 and then divide by 50, but there's an easy way to get from 50 to 400. I know that 5 times 8 is 40, and I can add a 0. So that means I can multiply 50 times 8 to get 400, which also means on the top, I can do the exact same thing. I can multiply 14 times 8 and get my answer. So we've got that problem set up. 8 times 4 is 32. Carry my 3. 8 times 1 is 8, plus 3 is 11. So I would expect that X equals 112 students that will be entering the education field out of 400 students. So that is our prediction for number 4. Okay, pause and make sure you get your work. So now we are looking at problem number 8, which is our final problem. It says a certain thrift store claims that they buy used jewelry at an average of $48 per necklace. The amounts the store paid for the last 4 necklaces are in the graph below. Based on the data, how much less than the store's advertised average is the more appropriate representation of the average payment? So remember, average is a fancy word for mean. So we need to add all of these up and divide by how many we have. So I'm going to start with our highest amount, which is 160. And I'm going to add, check, 15 plus 5. So that gives me 20 more. So that puts me at 180. And then I'm going to add the $12 to it as well. So that puts me at $192 for the total for all 4. But remember, we want the average. So we're going to take 192 and we're going to divide by 4. Well, I know that 4 does not go into 1, but it goes into 19 4 times. 4 times 4 is 16. So I'm going to subtract. I have 3 left. Bring down my 2. When I divide that, we get the 48. So we have just proven that when they say the average is $48 per necklace, that is indeed true. But if we look at our data, most of our data is about $15 or less. And we have that one piece of data that's outside the normal. So that means the average is not the appropriate piece of data to use. So we're going to use some other pieces to check. So we used mean. We can also use median to check. If I were to use median, that would be 5, 12, 15, and 160. So remember, the median is the middle number. So we want the middle of 12 and 15. So I'm going to add 12 plus 15, which is 27. And then I'm going to take 27 and divide it by 2. So that gives me 1. Bring down my 7. 2 goes into 7 3 times. Make sure we can tell that's a 3. Here we go, that's 6. We're at a digit, so add a decimal point and a 0. Bring my decimal point up. Bring my 0 down. 2 goes into 10 5 times. So that means my median is $13.50. Okay. We do not have a mode because there is no piece of data that is there most often. Okay, we can also look at our range, which is 160 minus 5, and our range of our data is 155. So the range isn't going to help us. Since we have one piece of data, this one piece, that $160, that is so far off from the other pieces of data, the mean is not a very good representation of the data that's there. So we're not going to use the $48. Since there is no mode, we're not going to use mode to represent our data either. And range is not a good representation. So that means the best representation of the data is the median. So we're going to focus on the $13.50. And the question says how much less than the store's advertised average is the more appropriate representation. So it's $13.50 is our median representation. That is our best representation. And since it says less than, we're going to end up subtracting. So when I set up my problem, I'm actually subtracting our mean minus our median. So that's 0. We have to go borrow, so that's 7. This becomes 10. 10 minus 5 is 5. Put my decimal point. 7 minus 3 is 4. And 4 minus 1 is 3. So that means that our best representation of the data, and compared to the mean, there is a $34.50 difference. That one piece of data, that $160, is definitely not part of the other pieces of data that are closer together. So having that one piece of data that's so far off from the rest of them will make sure that if you used an average, it will skew or kind of mess up or give a misrepresentation of your data. The median is a better representation. That way you kind of kick out the high and the lows if you're using the median. So that completes your test review. Get ready for your test. If you turn in your review, that's worth 5 extra points added to your exam.